In this video, we'll be looking at energy changes in chemical reactions. We'll be covering what exothermic and endothermic reactions are and the associated energy changes with both. We're looking at some of the examples that you should be aware of with exothermic and endothermic reactions at Gcse, and also how to represent energy changes in the form of energy level diagrams. During a chemical reaction, chemical energy stores either fall or rise in the chemicals that are reacting. If the chemical energy stores fall, energy is being transferred to the surroundings, and the surroundings usually feel warmer. That's an exothermic reaction. If the reacting chemicals are absorbing energy from the surroundings feel cool, and the chemical stores rise. That's an endothermic reaction. Exothermic reactions give out energy, so there's a temperature rise. To start off the reaction between iron and sulfur, for example, you must heat the mixture, but pretty soon it glows red hot, without the Bunsen burner. Mixing colourless silver nitrate solution and colourless sodium chloride solution gives an insoluble white solid precipitate of silver chloride and an associated temperature rise. When you add water to lime, heat is given out, so the temperature rises. Here, the temperature rise is being measured using a data logger. The chemical name for the lime is calcium oxide. So in an exothermic reaction, the products have lower energy than the reactants, and this is shown on this energy level diagram. Energy is measured in kilojoules. For the first reaction that we saw between iron and sulfur, the energy change is minus 100 kilojoules. It just so happens that we get 100 kilojoules of energy given out when the amounts of reactants in the equation are 56 grams of iron and 32 grams of sulfur. But don't worry how we get these amounts until later in the course. The minus sign shows that energy is given out. Endothermic reactions take in energy from their surroundings. When barium hydroxide reacts with ammonium chloride, the temperature falls so sharply that if you place some water droplets under the beaker, the water freezes. The white powder sherbet is a type of candy that actually contains two chemicals, citric acid and the base sodium hydrogen carbonate. When dissolved in saliva, a neutralization takes place, and it takes in heat as well, so your tongue cools down. This crucible contains calcium carbonate. If you keep on heating it, the calcium carbonate will completely decompose to calcium oxide and carbon dioxide. It's a type of reaction called thermal decomposition, which again takes in energy from its surroundings, so it's an endothermic reaction. We've just seen 3 examples of endothermic reactions, and in each reaction, energy is transferred from the surroundings into the chemicals that are reacting as the reactants convert to products. Since energy is taken in, the products must have higher energy than the reactants, and this is shown on this energy level diagram. In the last reaction that we saw, the thermal decomposition of calcium carbonate, 178 kilojoules of energy is needed to make 100 grams of the calcium carbonate decompose. We can express this by putting a plus sign in front of the 178 kilojoules. The plus sign shows that energy is taken in. Now it's your turn. Have a go at these questions and leave your answers in the comment section below. Then compare your answers with those that have been written by people who have previously watched the video. I hope that you found this video really helpful. If you have, please leave a like and support the channel by hitting the subscribe button. Best of luck with your GCSE exams. Take care. Bye.